UDC.
My name is Bill Larkin. I'm the UDC account manager for Ameren, and I've had the great pleasure of working alongside Jason and Sarah in implementing the Gas GIS replacement project that we're here to talk about today. First, a little background on Ameren. Ameren is an integrated gas and electric utility serving Illinois and Missouri. At approximately 2.5 million electric customers and almost 1 million gas customers, they're among the largest providers of electric and gas service in their jurisdictions. Like many utilities of their size, they've grown through the consolidation of smaller regional utilities, and one of the major goals for the current set of projects at Ameren is to put in place a common set of processes and systems for the 8,500 employees charged with maintaining those assets. Our focus today is on Ameren's transition to a linear reference model for managing transmission assets using Esri's ArcGIS Pro platform with the Advanced Pipeline Referencing extension. This project, however, is part of a much larger program that's building a new common foundation for all asset management and field operations functions at Ameren. The program consists of 3 major components: GIS projects for conflating all electric and gas assets to a common land base, replacing a dated and heavily customized GTEC GIS with an up-to-date enterprise solutions from Esri and Schneider Electric, and augmenting and improving the accuracy of existing asset data by digitizing paper records. The second collection of projects is the graphic work design project implementing Schneider Electric's designer tool. And finally, the Maximo projects are providing significant upgrades to the existing Maximo work and asset management platform, including better integration with the new GIS and GWD solutions. These projects at Ameren were started in earnest in the spring of 2018 with the Spatial Realignment Project. Ameren went live with the new Gas GIS platforms in the fall of 2019. The gas distribution assets utilize Esri's ArcGIS and Schneider Electric's ArcFM solutions, while gas transmission utilizes Esri's ArcGIS Pro with the Advanced Pipeline Referencing extension. The initial release of the graphic work design tool went live at the end of 2019. Ameren expects to go live with the new GIS solutions for electric in the fall of 2020. The new gas solutions will be upgraded to version 10.6.1 concurrent with the electric go live later this year. With the new GIS, GWD, and Maximo systems of record in place, Ameren can continue to extend their systems of engagement in 2021 and beyond. In particular, upgrades to the latest versions of ArcGIS Pro and APR are in the planning stages. And that's really what we're here to talk about today. So I'll turn it over to Jason and Sarah to discuss some of the benefits that Ameren is deriving from the shift to linear referencing paradigm and some of the challenges and lessons learned along the way.
Thank you everyone for joining us. I'm Sarah Skalon, Supervisor of Illinois GIS and Records at Ameren, and today I'm going to go in depth and share some ideas and lessons we learned while migrating to the linear referencing system in Pro. So first, what is linear referencing? It's spatial referencing where facilities or events in GIS are placed along linear features based on measurements from a fixed point, which is typically the start of a route in ArcGIS pipeline referencing, or APR for short. So why did Ameren choose to go towards a linear referencing system? What are the benefits? Prior to linear referencing, we were recreating stationing every year to run class and HCA. This was inefficient and subject to change each year. APR maintains that stationing for you, so calculations for class and HCA are more readily available and much more accurate. To meet data integrity needs, we were maintaining separate databases, and with this model, we're able to consolidate the amount of locations in which we store and analyze our data. Our legacy system didn't allow for the ability to import GPS. With APR, we could utilize stationing in conjunction with GPS-collected assets and imagery to place new events in accurately represented locations. This current process will continue to improve our GIS and placements of our facilities. Finally, something we're all familiar with, industry standards continue to evolve. With continuous updates and support to the platform and model, we can arrive at well-thought-out solutions for mapping and maintaining our GIS. So now that you know what linear referencing is and what benefits can come from it, let's go through some lessons learned. Once the decision is made to migrate, it's time to prepare. First, choose your team. Specifically for the linear referencing portion, we had a team of 5 experienced GIS users that we used throughout the entire process. Having these experienced users made troubleshooting, data corrections, and updates much easier to work through. Don't throw yourself or your team into a sink or swim situation. Prepare for ArcPro if you're an ArcMap user. Although a majority of the functionality is the same, the actual look and feel is much different. Our team was made up of seasoned ArcMap users, some of which had made the switch to Pro about a year prior to migration for general use. However, the rest of the team quickly followed suit when they found out that we were migrating. If you're completely new to Esri products, don't worry. ArcGIS Pro with its featured ribbon is user-friendly for both new and seasoned users. Clean up your legacy system. Do you maybe have geometry issues such as gaps or cutbacks that need updated? Do you have the need to conflate your data? Are you planning to? Don't overlook data modeling either. Clean up your domains. Do you maybe have some relationships between features that would make the system better? Maybe you have fields that were added from a legacy company that are no longer in use. These are all valid questions to ask your team, subject matter experts, and other departments who would have good constructive feedback. When doing a migration, don't forget to ask transmission integrity, standards, compliance, and other groups what should be collected and maintained in GIS, and what would maybe best be suited in asset management or other systems. And think ahead, setting yourself up by adding fields for the utility network or GNSS satellite attributes will be less that you will have to ask for later. APR utilizes routes which have rules to work properly in the network. Routes are unbroken, continuous with one start and one endpoint, and they must be unique. Routes store the measure values on the vertices to keep track of distance along the pipe, so in short, routes are extremely important to maintain. Route names are determined by the user, and we decided on a smarter naming convention so that any user could decipher what line they were looking at. We've been maintaining transmission route names for years, so we decided to utilize what we already had. For transmission, we used TR for transmission route, HPD for high pressure distribution, and SF for storage field. To remain consistent, we chose 3-letter suffixes on the end of the route name with parent-to-child relationships, so you can see below the different codes we created based on our system. If you chose a smart naming convention, you may have more or less if you decided to go this route. If a lateral had another pipe branching off, the offshoot was considered a child. So you can see below in the screenshot that one of our laterals is lat 2, while the one branching off is 2_1, same with the screenshot with the blowdown next to it. We chose this because our names were based on some type of relationship, whether it be the gas system, transmission route, or the location. Additionally, once we went live, we created a route picker tool. So the mapper enters the current route name, and the tool automatically generates the next number in the sequence. This ensures that we do not have duplicate route names. So what are some lessons learned from route naming? First, we had 2 people working on route naming and cleaning them up during dry runs. Route naming was completely manual and time-consuming, and months down the road, it became difficult to train others on the process. It was well worth it. However, if you're going to go with that smarter naming convention, make sure that you overestimate the amount of time and the amount of people that you need. Early on, we created a model to run on our pipes that dissolved them, calculated part counts, and delivered the results, and you can see below it is a very simple model. I suggest creating one that's similar and running it often. You do not want to get to the end and realize that you have hundreds of multi-part routes that you have to go back through. For complex areas, such as updated stations, we were unable to keep up with the naming of routes during each dry run. To make APR run properly, we assign these stations GUIDs for route names and currently have thousands of GUIDs to go back and reassign. Avoid them as much as possible, again, if you're going to go towards that smarter naming convention. And finally, probably the most important is communication. There were several large projects taking place at the same time, one of which was conflation. We had a majority of our geometry issues fixed, however, we didn't always have the latest cut of data to work from or know their timeline. Find different means of communication that works for everybody, and make sure to over-communicate and do it often. As previously mentioned, our system is made up of several legacy companies. One legacy company had no pipe represented in stations, whereas another had full details. To support the geometric network and be more consistent across the company, we chose to represent all stations schematically. For complex stations, we used existing records, georeferenced them in GIS, and then modified the overall look of the station by digitizing them based off prints and imagery. So you can see in the top picture what our stations used to look like, and then the bottom one is what we ended up going towards. What are some lessons learned? So make sure that you have the most up-to-date drawings. Some folks provided drawings we used, and then once in production, we realized that they were out of date and that the station had been updated. It's difficult to change production data, so please make sure that you have the most up-to-date drawings. If you have more than one person working on this, ensure your team is using the same projections and imagery. We had 2 people working on this at one point, and they were using imagery from different sources. This caused issues when one person ended up taking over. How are these changes affecting compliance? Consult your compliance team and ask if special care needs to be taken if you decide to change your GIS, specifically if your compliance system and GIS are synced. And although I've stated this before, overestimate the amount of time that you need. As GIS users, we know that the first, second, sometimes even third solution do not always go as planned, so give yourself and your team time to work through issues. When we migrated over, we didn't think ahead to precision lengths. Once live, we realized the precision was set to 6 to 8 digits, which for the end user is confusing. Although it sounds like a minor change, this gets back to data modeling and ensuring field rules, even down to the precision of decimals, is discussed. We have run into data issues due to our precision not being set to 1 digit, so make sure to have discussions with your conversion vendor about whether or not this would be a requirement for you. So let's talk about patches and workarounds. So here is the product roadmap released by Esri earlier this year. ArcMap with server 10.2.1 moving to 10.6.1 have done quarterly utility patch updates to release stability fixes, which makes planning ahead straightforward. Additionally, ArcPro extensions such as APR have been tied to full product release dates. The product roadmap released by Esri allows us the ability to see what's coming in the near future and plan for long term, specifically focusing on workarounds when problems are encountered. Directionality is on Esri's roadmap for a future update, however, it did require a current workaround for us. The direction for routes in APR is extremely important to the model. Direction determines how measures will increase and decrease geographically. We did clean up route directions best we could prior to migration, and we determined that if the first and the last segment of the route were going the same direction, the entire route and all pipe events would end up going to the desired direction. However, once we went live, we did find routes that were going the wrong way. In base APR, there's no built-in function to flip a route. A user can flip the direction of the center line, but the route and events do not automatically get new measures nor change direction, essentially defeating the purpose of the LRS model. We created a tool in-house that lets the user specify the route that needs flipped, and the tool automatically flips it, updating all measures for the route and events, and appending them back into the proper database and feature classes. In Pro 2.2, we currently don't have the ability to use attribute rules. We created add-ins to update these attributes for us, such as updating an attribute to be uppercase, or calculating one based on a feature intersecting a polygon, such as your town, city, or operating center. We're still about 8 months away from moving to the latest version of Pro, and it's been helpful to start learning attribute rules in Arcade. This is helpful to create an understanding of what's possible in the core product while trying to minimize future custom add-ins or code. So what are our next steps short term? So currently, events honor route measures. If we have an accurate GPS location for, say, a valve, but we didn't receive a good stationing measure, the event moves and maintains that stationing value. We have found that a simple change at the beginning of the route can cause a large amount of cleanup downstream. This functionality is on Esri's roadmap, but we're looking for possible solutions prior to the next upgrade. As with any conversion to a new system, we're continuously working on positively embracing change and adapting as we upgrade to the latest platform. It's important to let your team know the why behind the conversion and that no question is off the table. Because LRS is different than our legacy system, we're working on teaching users how stationing works and how it can make placing events easier and more accurate in the future. We're looking ahead to the future of tracking and traceability as well, and determining whether or not stationing can be used in locations where many events, such as welds, are clustered in a small area. And finally, with the input of weld and heat numbers into our data, we're working on creating a way to display these in a linear manner, not a point feature as we currently have. Our next steps, as with any migration, is to upgrade to the latest platform, hopefully first quarter 2021. We want to work towards reducing custom code as much as possible and to continue to work towards implementing the latest updates from Esri. This concludes our presentation. Thank you to all who have joined us, and thank you for taking the time to listen. Please reach out to any of us if you have additional comments or questions regarding APR or migrating to Pro. Thank you.
UDC